Before class assignment number 7, a CAD review of assemblies and drafting. For 5 points, I want you to complete those first 3 bullet points before class. Watch the tutorial video, download the 13 components for the ArborPress from iLearn, and assemble the components, and make sure to include a motion constraint so that the ram moves linearly the correct distance as the pinion gear rotates. And then for the remaining 5 points, those 2 bullet points you can complete during class time. Create an exploded view, create a drafting drawing showing an exploded view, an assembled view, and a parts list with balloon callouts as shown on this page here. So during class I want you to create this drafting view. Let's go ahead and get started. First you'll need to download these 13 parts from iLearn. Let's do a new assembly. And we'll bring in the very first part, the frame. And you'll notice that when I bring in the frame, it shows this little push pin. What it's done is it's grounded the first part so that I don't have to constrain it at all. It's grounded it so that it can't move. So now I can go ahead and bring in the second part. Let's bring in the ram. And we'll constrain this ram. We'll bring this plane mated with this plane. We will take this datum plane, center datum plane here, and that's all the constraints that the ram needs. We can see that we can move it up and down, but not side to side. Let's now bring in the pinion shaft. The pinion shaft will need an insert constraint. Let's insert this circle up against the edge of this hole. There's the pinion shaft, and now let's put a motion constraint between this pinion shaft and this ram, and we'll make it this linear circular to linear constraint, and we'll choose this option so that as we rotate it moves the direction that we would like it. And because it's a 1-inch pitch diameter, every time I rotate the pinion, the ram should move pi times the pitch diameter. Let's apply that. Okay, so now as I grab a hold of this pinion and I rotate, the ram will move the correct distance because I specified that in a motion constraint. Okay, now let's go ahead and bring in the next part. We'll bring in this face plate. We're not ready to constrain it yet, because we need to bring in the jib plate first. Let's bring in the jib plate, and we'll go ahead and now constrain the jib plate so that it's out flush with this face, and let's make sure it's centered in the face plate. So we'll take that plane and this plane, bring them together, and we'll do it vertically as well. This plane and this plane, and make those flush. So now the jib plate is inside the face plate. So now we're ready to bring the face plate up against the main frame and to center it. Okay, so now we have the face plate on. We're ready to go grab another part. Let's grab the table plate. We're not quite ready to constrain it yet because we need the groove pin. Okay, so now let's constrain this groove pin. I'll use an insert constraint, inserting the end of the groove pin up against the end of this hole with that option. That's a press fit. That groove pin has a groove, and so you'll pound it in and it'll be wedged into that table plate. And now let's take the edge of this hole and insert it up against the edge of this hole with that option. Let's bring in another part. Let's now bring in the lever arm, and we'll constrain it. Let's take this center axis and put it inside this center axis. And then we'll take also this plane and we'll mate it up against the datum plane for the center of the pinion. Make it flush. So there's the lever arm, Now let's go ahead and bring in the caps, the handle caps. We're going to need 2 of those, so we'll place 2 of them, and we'll constrain it with the insert constraint. We'll grab the bottom edge of the hole and insert it up against that handle. We'll do the same with the other cap on the other end. Okay, now let's go ahead and bring in the collar. We'll take the insert constraint and we'll insert the edge of this up against the edge of this hole. Apply that constraint. And now let's take also the center plane. We want that to rotate with the pinion shaft, so we're going to align the planes with this flush constraint. I'm going to go ahead now and turn off all these datums that are becoming such a nuisance to look at. I needed them so that I could constrain some datums together, but it also makes it a nuisance to look at, so we might need to turn those on and off as we place different components. Now let's bring in the set screw. And I'll place the set screw here, and the first thing I'm going to do is rotate this set screw so that it's approximately in the right orientation so that the computer can assume the correct position when I make these constraints. What I'll do is I'll take this center axis and align it with the center axis of the collar and apply that. So I will make another constraint, and I'm going to take and make a tangent constraint of this face, tangent up against that cylindrical face of the shaft. That places the set screw in up against the shaft. Okay, now let's place some thumb screws. 1, 2, 3 thumb screws. And I'm going to go ahead and rotate those and orient them so that they're roughly oriented the way they would need to go into the assembly. That way the computer will assume correct constraints for me. And I'm going to make this one aligned with this center axis of this hole here. I'll take this one and I'll align it with the center axis of the hole here. And I'll also do the same with this one. Align it with this center axis of the hole. We'll apply those. Okay, but now we'll notice that these thumb screws can still be moved in and out. I haven't placed them up against anything. So let's do that now. Let's create a tangent constraint, and we'll bring that end face up tangent against this cylinder. We'll take this end face and put it up against the jib plate. And we'll do the same with this other thumb screw. That end face up against the jib plate. Okay, the only item I have left to bring in is the cap screws, so let's bring in the cap screws, and we'll place 1, 2, 3, 4 of those, and we're going to use this insert constraint to place those cap screws. We'll insert the top shoulder onto the edge of this hole, top shoulder here onto the edge of this hole, top shoulder here onto the edge of this hole, top shoulder here onto the edge of this hole. Okay, now we're assembled, and if we wanted to, we could grab this arm and we could even move it and watch the arbor press operate, because we've put that motion constraint. So this completes the before class portion, which is worth 5 points. Okay, now that we've completed this assembly of our arbor press, let's create an exploded view. We're going to do a new, and this time a IPN file, which is a presentation file. Let's tell it which view we want to bring in. We want to bring in the assembly into this presentation file, and we'll manually create the explosion. And we'll view it from this angle. And let's go ahead and tweak some of the components. The first thing we'll do is we'll specify a direction. Let's just choose this direction. I'm going to be moving things in that Z direction. And let's choose all the components we want to move. All the bolts here, as well as that face plate, and let's also get the jib plate. So we'll use this toggle method to get the jib plate. And now let's go ahead and move those probably 2 inches. Let's go ahead and go 3 inches. And now we will unselect the face plate and unselect the jib plate, so that now I'm only moving the bolts, and let's go ahead and move those out 1.5. And let's clear that out, and we'll come around and we'll specify a direction for the jib plate. And we're going to move this jib plate, let's move it about 1 inch away. Okay, so now we've disassembled these portions. Now let's tweak this ram. We'll specify that direction, move the ram, and let's move it, should we say 1.5 inches? That looks good. Now let's pull off in this direction the collar and the set screw. And we'll move that about 1.5 inches out. Now let's move in this direction this set screw, and we'll move it about 1 inch out. Looks okay, so now let's specify a new direction, and we'll move the thumb screw, the handle, the 2 caps, and the pinion shaft, and let's move that out maybe 4 inches. Now we'll move in this direction. We'll move this handle and this cap, and let's move it, try 7. And let's unselect those 2 components and select this one. We could move this in 3 inches. That looks a little nicer. Okay, the next thing we'll do is we'll specify this direction and those 2 components. Of course, deselect this component. And let's move that probably 2.5 inches. Looks about right. Unselect this component. Let's move even -1.75. That looks better. And now we will clear that, and let's specify a new direction. Move this pin. We can move that out about 1 inch. Okay. But maybe I don't like all these trace lines. So if I don't like to see them, I could just make all those invisible if I wanted to. Okay, now that our exploded view is complete, now we're ready to do a drafting view. So we'll do a new drafting drawing. We'll fill in our title. We'll call it BC-7 Arbor Press. We'll put in our name and the class, ME280. Brings in a blank title block. Now let's place a base view. The first thing we'll do is place the assembled view. So let's go get the assembly. And let's make it a 1/3 scale, shaded, viewed from the top left. That looks good. Let's place another base view, and we'll get the exploded view. We'll choose this IPN exploded view, and let's make it also shaded and viewed from the top left. We're ready now for a parts list. We'll select a view. We'll make the parts list on the exploded view. I'll hit OK so that it will enable it. There's our parts list. So now let's create some balloon callouts that refer to that parts list. We'll do a balloon callout for each piece. I'll click and then right click and say continue when I'm finished.